We've discussed what drives plate tectonics and its ability to move continents, but it also produces massive amounts of stress within the crust that can lead to noticeable deformation. Crust deformation refers to changes in shape of the crust because the rock it is comprised of is being squeezed or stretched by workings of the earth beneath it. Squeezing is referred to as compression. Stretching is referred to as tension. Rocks can also be twisted or pulled across each other, similar to the way faults are at transform boundaries. These stresses are called torsion and shear respectively. All of these stresses can be visualized by imagining a slinky being squeezed, compression, stretched, tension, twisted, torsion, or pulled towards you with one hand and pushed away with the other, or shear. If rock changes shape because of stress, it can either bend or break. Bending of the Earth's crust is called folding, and breaking is called faulting. Folding of the Earth's crust is actually much more noticeable than one would expect. Most of the large mountain ranges in the world formed when compression caused the land to fold up. Even when looking at layers within rock, waves of upward and downward folds often appear. Upward folds are called anticline. Downward folds are called syncline folds, and folds that result in plateau-like rocks that are parallel at both ends are called monocline folds. The lower image demonstrates such a monocline fold. When stress grows to sufficient levels for the Earth to actually crack, you have a fault. Faults, or cracks in the rock, can be categorized into one of several types based on where the blocks of rock slide. In a normal fault, tension pulls rock apart, and one side slides down and away from another. The piece sliding down is called the hanging wall, and the part raised above the other is called the footwall. When the opposite occurs and the hanging wall slides up and over the footwall, it is described as being a reverse fault. Reverse faults are caused by compression and look like one piece has slid up and into the other. Shear causes strike-slip faults, in which the two pieces of rock slide horizontally past each other, similar to the way boundaries slide past each other at transform boundaries. In this diagram, the top image is an example of a normal fault, the middle is an example of a reverse fault, and the bottom is an example of a strike-slip fault. Hopefully, you've noticed the grouping emerging between the form of stress and the type of rock movement that it causes. Compression takes place primarily at convergent boundaries and causes reverse faults. Tension is strongest at divergent boundaries and causes normal faults. And shear is strongest at transform boundaries and causes strike-slip faults. One of the results of folding and faulting is the formation of mountains. Most large mountain chains have formed because of folding. When compression between tectonic plates causes crust to fold up, long chains of mountains can appear surrounded by smaller foothills. The Himalayas, the Rockies, Andes, and Appalachian Mountains all formed this way. Other types of mountains form because of faulting. Tension in the crust can cause a series of normal faults to occur in the same area, leading to the creation of a series of uneven peaks. When coupled with the effects of weathering and erosion, these fault-blocked mountains come to resemble more traditional mountains. The mountains surrounding Death Valley formed in this way. We haven't discussed volcanoes yet, but they can also lead to the formation of mountains. Just beyond subduction zones, magma near the surface builds up, erupts through the surface, and slowly piles up, forming a mountain of volcanic rock. Many of the mountains in the Pacific Northwest are such volcanic mountains. Some of these volcanic mountains are mixed in with folded mountain ranges, building both through compression and eruptions. Increases in elevation, such as takes place during mountain building, are called uplift. Mountain building isn't the only form of uplift, though. If weight is removed from the crust in any way, it can float a little higher in the atmosphere. When this happens, it will raise up a little with minimal deformation. The opposite taking place when a segment of the crust lowers in elevation is called subsidence. This can occur when rock cools and increases in density as a result of massive faulting, or if material underground is removed. The clearest example of subsidence would be sinkholes or the collapse of underground caverns.